Right, so we're starting to look now at a new sort of a topic, which is, I can't get it down that far, optimization. Okay, so we're going to start off with the one variable type of optimization, where you're trying to optimize something, generally trying to find a maximum or a minimum or something along those lines within a sort of a context. Okay, we're quickly going to expand on this real quick, but through this one here, we are trying to find a maximum temperature. That's this temperature. T represents the number of minutes. Okay, so we're trying to find the maximum temperature. How do we do that? Maximum temperature, we have to differentiate. Okay, so we go, let's differentiate it. So y dash is now equal to, that is a function over a function. So that is the quotient rule. So let's do the quotient rule. I write down the bottom one. So t squared plus 4. And I differentiate the top one. So that's 40. And I subtract away, I write down this top one, and I differentiate the bottom one. Now that is 2t. And this is all divided by the bottom one squared. Happy with that? All right. What am I going to do here? What am I going to do next?
Expand the brackets. That simplify it.
Top line and bottom line? Do I need to do that on the bottom line?
No.
Why not? We're looking for a maximum, aren't we? So we're looking for a maximum. What does a maximum imply?
Gradient equals 0.
The gradient. So it implies that our derivative there is equal to 0. How does that equal 0?
The top is 0.
The top is 0. It's got no reference to the bottom. Okay? The bottom can't be 0, can it? Because if it was divided by 0, then it'd be undefined. So it has to be the top line. So no actual fact, we're only interested in the top line here. So we're only interested in the t squared plus 4 times 40 minus 40t times 2t. We're not actually interested in the bottom part. So yes, we expand these brackets. So that's going to be 40t squared plus 160. Is that right? So we're minusing 80t squared, and that equals 0. That's a quadratic equation, so let's just collect all our like terms, and let's go 160 minus 40t squared equals 0. How do I solve a quadratic equation? Factorize. Is there a common factor in there? 40. So I'll take the 40 out, and that is 4 minus t squared equals 0. From there, it's this part here that has to equal 0. So what does t squared have to be? 2. Or equals plus or minus the square root of 4, which is plus or minus 2. You guys happy with that? So does that give us our answer?
No.
We're after the maximum temperature of these brake pads. How do we find the maximum temperature? Yeah, so in other words, when time is 2 minutes, the temperature is 40 lots of 2 over 2 squared plus 4 plus 20. Just trying to read that top part there as well. Happy with that? So that's 80 divided by, that's 8 That is 80 divided by 8 plus 20, which is 30 degrees Celsius. Yeah? Happy with that? Happy with that? Now, should I try and prove it's a maximum?
Yeah.
Should I prove it's a maximum?
No, you could, but you don't really have to because you can't just make it a time.
No, this could be a minimum. This could be the minimum though. We have to prove that 30 is the maximum. Okay? How could you prove that? Differentiate again. How else could you do it? What about if you put in time of 1.9? What would you get?
Something smaller.
Something just smaller. If you put 2.1, what would you get?
Something just bigger.
Something smaller as well. That's why it would be your maximum. That's one way of doing it. Okay. A few different ways of doing it. It's just either way. Just make sure you do it. Questions with that?
Yeah, sure.